Hi everyone, and welcome back to this series of tutorials about using WEKA to classify and to use machine learning in the context of different power system asset problems. And in today's lecture, I'd like to revisit something we went very fast, which are the metrics used to distinguish between different classifiers, and so that we can tell which classifier is better than the other. And these metrics include recall, precision, classification accuracy, and so on and so forth. So I will start with this slide that we covered before, but I want to go through the confusion matrix because it has four important terminologies that will be used a lot in the calculation of those metrics. The first one is true positive. To explain this, let's assume we have a classification problem that is binary. So let's say we want to classify transformer oil as good or as bad. So it's two classes. So we have the class of bad and we have the class of good. So only two classes. So what does it mean true positive? True positive means that the transformer oil is actually, for example, good and classified as good. So this is what is meant by true positive. On the other hand, true negative, the transformer oil actually is not good, could be bad if it's it's a binary problem, or could be if it is multi-class problems, could be anything other than good. So the sample is not good and it's classified as not good. So we call it a true negative. Okay, so this diagonal, we want to see it as high as possible. Okay, now let's look to this item, and this item we have false negative and false positive. What is the difference between these two? Now, false positive, that the oil sample actually is not good but classified as good. It's not good, so it's classified as a good sample, but by mistake. On the other hand, the false negative, the transformer oil is good, but it's classified as bad. So this is called false negative. Now, when we understand these four terminologies, then we can find what we call the precision, which is a ratio between the TP divided by the TB plus FP. Of course, TB is true positive and FP false positive. And then the recall, which is TB over TB plus Fn. So they are very similar. The only difference is FP and Fn. And then F1, this is a third metric that is used as a sort of a weighted average, and we'll talk about that later on. And of course, there is the overall accuracy, which is the summation of this diagonal elements, the true positive and the true negative, divided by all cases. So I will use data that we published or we made before, a transformer oil, when we had the three classes, the good, the marginal, and the bad. And we will try to go deeper and try to actually try to understand every single item more based on this specific data and do the calculations ourselves. Okay, so we'll start with the overall accuracy here. This is just a snapshot from WEKA results. This is the final results after we finish the classifier. So what is this? This is how many samples were correctly classified and how many samples were misclassified. How we reach to this number? Very, very simple. We just divide this by the summation of truth. So this is our overall accuracy among all the classes. Okay. Then we talked about this little bit, which is the true positive rate. Okay, so the true positive rate, we'll do it for all the three classes. So true positive, or for the bad sample, it is the 140 divided by the 140 plus 2 plus 3. So all misclassified sample from the same class. True positive for the marginal, we have 12 samples that are correctly classified, and total sample is 31 plus 12 plus 35, and this is what we talked about it last time. We have a very low true positive for the marginal. Finally, true positive for the good, which is again the 502 divided by the summation of all these samples. Okay, so that is this column, the true positive rate. Let's move to the second one, which is the false positive. False positive. So it means that the sample will classify, for example, as bad, but it's not bad. Okay, so we see here these 32 and these two will classify it as bad, but this 31 is actually marginal, and these two are as good. So how to calculate these ratios? Very simple. You add these two, the 31 plus 2, divide by the whole number of the cases of the marginal and the good, which is 31 plus 12 plus 35, and 502 plus 2 plus 3. Okay? So among all these cases from those two other classes than the bad, we have 31 plus 2 were misclassified, and this we call it the false positive. Same thing for the marginal. Now the marginal, we have 3 and 2 were misclassified. Divide by the summation of the whole class, this plus this, of the where the misclassifications happened. So it was 140 plus 2 plus 3, 502 plus 3 plus 2 times 100. So this is actually not 7.6%, it is 0.76%, which is the 0.008. And here's something interesting. Although the margin is bad, generally speaking, but in this metric, it's not. It is the best actually, because false positive, you want this to be as low as possible. Then finally, the false positive for the good is basically how many misclassified as good. False positive 3 and 35. These 3 should be bad. This 35 should be marginal. Those are classified as good, and divide by the summation of these two classes, the bad and the marginal. 140 plus 2 plus 3, 31 plus 12 plus 35. So it's very obvious now, as I mentioned before, that we want this to be as low as possible. This is opposite to the true positive. Now let's talk about precision. So this is the precision values. How we calculate the precision? Precision is basically, this is the formula for that. It's the true positive divided by the true positive plus the false positive. Or it is the ratio of the correctly predicted positive observation to the total predicted positive observation. So what is correctly, for example, a positive means that, okay, it is good and classified as good. So this is the correctly predicted positive, divided by everything classified as good, either it was really good or was other classes. So from this definition, it's clear that is 140 divided by the summation of the whole column. 140 plus 31 plus 2. If you go to the precision, this is precision for the bad. If you go precision for the marginal, you go for this whole column, 12 divided by 3 plus 2. And again here, the precision is not that bad. It is 70.6%, which is very comparable to the bad. Finally, the good, the precision is the 502 divided by the whole column. So precision is division of the item with respect to the column. Okay, let's go to the recall. Recall is how many of true positives were recalled or refound, okay, or found. And now this is exactly, you will see that the recall and the true positive are the same. Okay, so you see they are the same numbers. So recall for the bad, it is 140 divided by the raw. So precision, the 140 divided the summation of the column. The recall is the 140 summation of the row, the whole row. So it's 140 plus 2 plus 3. Recall for the marginal, it's 12 divided by the raw. Again, it's unlike the precision. And finally is the recall of the good is the 502 divided by the whole sums. Now, one thing you notice when you look at the precision and the recall, precision, for example, for the marginal is really is not bad, but when it comes to the recall, it's extremely bad. Sometimes you will find that if you increase the recall, you decrease the precision and vice versa. So you will ask yourself, which one is better? So we have to have a sort of weighted average between the precision and the recall, just one number, and use this number to differentiate between the classifier. And this is the if measure. In the if measure, basically it is 2 times the precision times the recall divided by the summation. As simple as that. So when you look here for the if measure for the bad, which is this value, you multiply the 0.809 times the 0.966, and you divide by their summation, you get the 0.881. Okay, and so on and so forth. The if measure for the marginal and the if measure for the good. So if you want to find one number that somehow include both the recall and the precision, it is the if measure. So this is a general view about the different metrics we use to distinguish or to quantify the efficiency of different classifiers. Thank you for joining me, and looking forward to meet you for more presentation.